Hello and welcome to day 2 of probability. We are going to talk today about independence and conditional probability. Now, first up is our index card of the day. What is the formula for probability? Now, there's two different ways that it can be written, and I'm going to show you both ways. It is the probability of A and B equals the probability of A plus the probability of B minus the probability of A or B. That's a minus, right? This is your and, this is your intersection, and that's your or. So A and B equals A plus B minus A or B. And let's just fix that so it looks really like a minus sign. Minus, there we go. All right, so that's the way to write the probability formula when you're solving for the intersection for A and B. But that equation can also be rearranged so that you're solving for the probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. Right, A or B, A and B. And again, this is just taking A and B, A or B, and just switching the order, because since this is subtraction, you can add it to the other side, then subtract that over to the other side. So you can very easily rearrange this formula to solve for A and B or A or B. All right, so today we're going to talk about independence of two events. So independence means the outcome of the first event does not alter the probability of the other event. Two events A and B are independent if the probability of A and B occurring together is the product of their probabilities. So if you find A and B, it's the same as finding the probability of A times B. Two events are, mutually exclusive if the probability of A and B equals 0. That means that they cannot occur at the same time. So let's look at example number 1. Given events A and B such that the probability of A equals 0.3, the probability of B equals 0.7, and the probability of A or B equals 0.8, determine whether A and B are independent or dependent and explain your answer. Now right away, make sure you underline that word explain to remind you that you have to answer with a sentence. Anytime it says to explain your answer, remember you have to answer with a sentence. If it says to justify your answer, that's just showing your work. But explain, you have to answer with a sentence. So we want to determine if events A and B are independent. So in order to prove that two events are independent, again, we need to use that formula, the probability of A and B equals A times B. Well, in this original problem, they gave us A, they gave us B, but they didn't give us A and B, they gave us A or B. So that's why it's so important to know the formula we talked about at the start of this packet. The probability of A and B equals A plus B minus A or B. So the probability of A and B, we know the probability of A is 0.3, we know the probability of B is 0.7, and we know the probability of A or B is 0.8. So add those up. 0.3 plus 0.7 is 1 minus 0.8 equals 0.2. So the probability of A and B equals 0.2. So we can now check for independence, because now we know that this probability is 0.2. Is that equal to, that's a question mark, is that equal to 0.7 times 0.3? Probability of A times probability of B. Well, 0.2 equals 0.7 times 0.3 is 0.21. Those are pretty close. So our conclusion, these are very close. So they are possibly independent. They're not exact. If they were exact, we would say that yes, they're independent. They're close, so we say that they are possibly independent. All right, let's turn the page. In a company, 43% of the employees have access to a fax machine, 38% have access to a fax machine and a scanner, 24% have access to neither a fax machine nor a scanner. Suppose an employee is selected at random. Calculate the probability the randomly selected employee will not have access to a scanner. So let's set up our two-way table. We have the probability that they have access to a fax machine or no fax machine, and our total. We have scanner, we have no scanner, and total. So 43% of employees have access to a fax machine. So remember, that means that entire row, right? 43% have access to a fax machine. So this total here is going to be 43%. %38 have access to a fax machine and a scanner. There's that word and. When you see that word and, that's your intersection. Fax machine and scanner, right? I want them both to be yes. That number goes there. Fax machine and scanner is 38%. 24% have access to neither. Remember, that word neither means not. No fax machine, no scanner. So that's the number that's going to go here. 24% have access to neither. Suppose an employee is selected at random. So remember, when you're talking about percents, your total has to add up to 100%. So to figure out all the other numbers, we just have to subtract. 100 minus 43 means that 57% do not have access to a fax machine. Go right to left. If you're starting with a total of 43% have access to a fax machine, subtract the 38 who have access to both. That means that 5% have access to a fax machine but not a scanner. 57% do not have access to a fax machine. Minus 24% do not have access to a scanner means that 33% have access to a scanner but not a fax machine. And then if I'm going down, I want total, I add those numbers together. 38 plus 33 is 71%, and 5 plus 24 is 29%. So now let's look at what they want to know from this table. Calculate the probability that a randomly selected employee will not have access to a scanner. So we're looking for the probability of no scanner. That's that entire column here. No scanner is that 5% plus 24%, which adds up to 29%. 29% will not have access to a scanner. For part B, are the events access to a fax machine and access to a scanner independent? So again, when you see independent, that's the probability of A and B equals the probability of A times the probability of B. Now in this case, we're not talking about A and B, we're talking about a fax machine and a scanner. So we can say, is the probability of a fax machine and a scanner equal to the probability of having access to a fax machine times probability of having access to a scanner? And this is what we're checking. Are these two numbers equal? So fax machine and scanner, fax and scanner was 38%, which is 0.38. The probability of having a fax machine is the total row of fax, which is 43%. Probability of scanner, total scanner row is 71%. So if you use your calculator and you multiply 0.43 times 0.71, you get 3053. So are those two equal to each other? No. So no. We can put a slash through here. They are not independent. All right, let's look at number 3. In contract negotiations between a local government agency and its workers, it is estimated there's a 50% chance that an agreement will be reached on the salaries. There is a 70% chance an agreement will be reached on insurance benefits, and there's a 20% chance that no agreement will be reached on either issue. Find the probability an agreement will be reached on both issues. So you can set up a two-way table, you can set up a Venn diagram, or you can just use the formula for this one. So I'm just going to use the formula because we want an agreement on both issues. So that's finding the probability of A and B, which is A plus B minus A or B. So in this case, we're not looking at A and B, we're looking at salaries and benefits. So let's let S equals salary and B equal benefits. So we want the probability of salary and benefits equals salary plus benefits minus salary or benefits. So we know the probability of salary. There's a 50% chance, so 0.50. Benefits is a 70% chance. Now, do we know salary or benefits? No, we don't. But we do know there's a 20% chance that no agreement will be reached on either issue. So if we know the probability of neither issue, we know that or is 1 minus neither. So if I do my 100% minus a 20% chance of neither, that is an 80% chance of or. So 0.50 plus 0.70 minus 0.80 gives me 0.40 or 40%. Either answer would be right. So based on this answer, determine whether the agreement on salaries and insurance are independent events. So again, remember what independent means. It means the probability of A and B equals A times B. Well, in this case, again, we're not doing A and B, we're doing salary and benefits, and we want to know, is that equal to salary times benefits? So salary and benefits is 0.40. Salary alone is 0.50. Benefits alone is 0.70. And 0.50 times 0.70 is 0.35. Is 0.40 equal to 0.35? No. So we would say no, they are not independent. So now question 4 says, for the problem above in number 3, what is the probability that an agreement will be reached on insurance benefits given that an agreement is reached on salary? So this is what we call conditional probability, and you can see it right above. The formula is on the top of the page. The probability of A given B. So whenever you see this straight vertical line, the vertical line stands for given. This is the probability of A given B. It means that you have some prior knowledge of something happening. So the probability of A given B is the probability of A and B divided by the probability of B. And again, whatever it is that you're given is what goes in the denominator. So in this case, what's the probability that an agreement will be reached on insurance benefits given that an agreement is reached on salary? That means we already know that they agreed on salary. We're trying to figure out what's the probability that they will now also agree on benefits given that they've already agreed on salary. So we're looking for the probability of benefits and salary divided by, again, whatever was given goes on the bottom. So the probability of salary. Now, in question number 3, we figured out the probability of salary and benefits, right? In number 3, we figured out the probability of salary and benefits was 0.40. Now, remember that when you are finding and, the order doesn't matter. So the probability of salary and benefits is the same as benefits and salary, because you're still finding that intersection. If you think about your Venn diagram, you're looking for where they overlap each other. So benefits and salary and benefits mean the same thing. That's 0.40 divided by the probability that they agree on salary, they told us in the problem, was 0.50. So 0.40 divided by 0.50 gives you an answer of 0.80 or 80%. So if we already know that they agreed on salary, then there's an 80% chance they'll also agree on benefits. Now notice that I used, again, decimals in this problem. For number 3 and number 4, when they give you percents, it's really important when you plug into the formulas that you convert them into decimals. If I had just done 40% divided by 50%, that would have still given me an answer of 0.8, but you have to know that 0.8, again, converts back to 80%. Number 5. Of the 650 juniors at Arlington High School, 468 are enrolled in Algebra 2, 292 are in physics, 180 are taking both. If one of the 650 juniors was picked at random, what's the probability they are taking physics if we know they are in Algebra 2? So let's say that P is physics and A is Algebra 2. So we want the probability that they are taking physics if we know, if we're given that they're already in Algebra 2. So this is, you're finding the intersection probability of P and A divided by, again, whatever is given. We're given the probability, we're given that they are already in Algebra 2. So we know there are 180 students taking both courses at the same time. So 180 out of the 650 students. And the probability that they're in Algebra 2, there are 468 students enrolled in Algebra 2. Now remember what happens when there's a common denominator? We can ignore the denominators. So we're left with 180 over 468. And in probability, again, you do not have to simplify. So if you get an answer of 180 over 468, you can actually leave it as 180 over 468. If you did simplify it, it would come out to 5 over 13, and that is also fine. All right, next page. The guidance department has reported that of the senior class, 3% are members of math club, 8% are enrolled in AP Physics, and 10% take math club or AP Physics. Determine the probability that a student is in the math club given that they are enrolled in AP Physics. So let's draw our two-way table. Of the senior class, 3% are members of the math club. So we need math club and no math club. And you always want a total. 8% are in physics. So that means we also have no physics. And a total. So look at the information again that we're given. 3% are members of the math club. That means the total math club has to add up to 3%, or 0.03. We know that 8% are enrolled in AP Physics. So AP Physics, total AP Physics is 8%. Remember, our total is always 100%. So right away, I know if 3% are in math club, 97% are not in math club. If 8% are in AP Physics, 92% are not in AP Physics. Now here's the last part that it's a little harder to find the probability. They're telling us that 10% are in math club or take AP Physics. Now that or, whenever you see or, it's these three boxes together. And because it's anything that's math or anything that's physics. So whenever you see the or, remember that or is 100% minus the neither, or the total minus the neither, and vice versa. If I want the neither, oops, I do that a lot. If I want the neither is 100% minus the or. So if I do 100% minus the 10% that are or, right, 10% in math club or AP Physics, that means 90% of students are in neither one. 90% of students are neither math and not physics. So that means that there's only 2% math, not physics, 1%, because I'm subtracting, 3 minus 2 is 1%, 97 minus 90 is 7% that are in physics but not math. So I want to determine the probability that a student is in the math club given that they're in AP Physics. So again, the formula would be what's the intersection, what's the math club and physics given that they're in physics. So math club and physics was 1%, 0.01. Physics alone, that total blue box, is 8%, 0.08. So 0.01 divided by 0.08, you can either simplify that to 1/8, or if you do 0.01 divided by 0.08, you get 0.125, or if you make it into a percent, that would be 12.5%. And any of those three answers would get full credit on the Regents exam. The next part of the question is asking us to explain exactly what this result means in the context of the question. So that number that we just found was the probability that a student is in math club given that they are enrolled in AP Physics. So what this is actually telling us is that although only 3% of seniors are in math club, if we know they are enrolled in AP Physics, then the probability they are in math club rises to 12.5%. An alternate way to say that is that 12.5% of AP Physics students are in math club. Right? Because if we know they're in AP Physics, right, that's what we're given is information. We're given that they are in AP Physics. So of those AP Physics students, 12.5% of them are in math club. So last part. Are the events member of math club and enrolled in AP Physics independent? So there are actually two different formulas for independence. Right? They're asking us independent. We talked about one of them earlier on page 8 and 9. We said the probability of A and B equals the probability of A times the probability of B. But on the top of page 10, we actually see that there is a second formula that can also determine independence. It's the conditional independence formula. And that says that the probability of A given B equals the probability of A. What that is saying is that when you are given some specific information, some B value, whatever it is that we know to be true. Let's say I know for sure that it is going to be sunny today. What is the probability that you use a blue pen given that it's sunny out? That should still be the same probability of using a blue pen, because whether it's sunny out or raining out, it doesn't affect what color pen you use. So those are the two formulas that we can use, and I'm actually going to use both to show you that you would end up with the same answer either way. So if we look at that table up top again, the probability, in this case we're talking about math club and physics, so the probability that you're in math club and AP physics, is that equal to the probability of math club times the probability of being in AP physics? So math club and physics was 1%, 0.01. All of math club was 0.03, and all of physics was 0.08. So 0.03 times 0.08 is 0.0024. So is 0.01 equal to 0.0024? No, it is not. So we can say they are not independent. Let's check the second possibility. What is the probability that you are in math club given that you're also in AP physics? Is that the same as just being in math club? So the probability of math club given that we know you're in AP physics was 12.5%, 0.125. Is that equal to the probability of being in math club? Probability of being in math club was 0.03. Are those equal to each other? No. So no, they are not independent. No, they are not independent. Right? 12.5% is very different than 3%. All right, one problem left. Turn the page. Number 7, historically a given day at the beginning of March in upstate New York has an 18% chance of snow and a 12% chance of rain. If there is a 4% chance it will rain and snow on any given day, then calculate each of the following probabilities. First, what's the probability it will rain given that it is snowing? So this is asking us what's the probability of rain given snow, which again, you have to know the formula for conditional probability. Probability of A given B is the probability of A and B over B. So in this case, we're looking at rain and snow. So do we know the probability of rain and snow? Yes, they told us 4%. Do we know the probability of snow? Yes, they told us 18%. So we don't have to set up our table because we know all of these values. So the probability of rain given snow equals the probability of rain and snow divided by, again, whatever you're given. We are given snow. We're given that it snows. Whatever the second thing is what you're given. So the probability of rain and snow was 4%, right? 4% chance it will rain and snow. So that's 0.04 divided by the probability that it will snow. It says there's an 18% chance of snow. So 0.18. 0.04 divided by 0.18 equals 0.2222 repeating, which can be written as 2/9 or approximately 22%. So again, any of those answers would get full credit. Part B, what is the probability it will snow given that it is raining? So now we're looking at the opposite, the probability that it will snow given that it is currently raining. So again, it's the probability of snow and rain divided by whatever's given. And we're given that it's currently raining. So remember I said in the other problem, rain and snow and rain mean the same thing. When you have that and symbol, the hill, the intersection, it doesn't matter which order it's written in, it's still the same probability of 0.04 divided by probability that it will rain. So they told us in the problem that there is a 12% chance of rain. So divided by 0.12, you get an answer of 0.3333, repeating, or that can be written as the fraction 1/3, or that is approximately 33%. So again, any of those three answers would get full credit. Same thing here. Any of these three answers would get full credit, since it doesn't specifically tell us what they want us to write the answer as. Part C. Are the events rain and snow independent? So again, remember there are two different formulas that you can use. You can use the probability of A and B equals A times B. So in this case, is the probability of snow and rain equal to the probability of snow times the probability of rain. Probability of rain and snow was 0.04. The probability of snow is 0.18. And the probability of rain is 0.12. So multiply 0.18 times 0.12 and you get 0.0216. So are those equal to each other? No, they're not. They're 2% different. If you use the second formula, probability of A given B equals probability of A. That's the conditional independence formula. So there's actually two different things we can check. We can check, is the probability of rain given snow equal to the probability of rain? And we can also check probability of snow given rain equal to the probability of snow. So the probability of rain given snow, that was our part A, was 0.222, repeating. Our probability of rain all by itself is 0.12. So is 22% equal to 12%? Definitely not. Snow given rain was 33%, or 0.33, and the probability of snow by itself is 0.18, which also clearly not equal. So no, they are not independent. If this was on the Regents, you only have to do one of those three formulas. You don't have to show all three. But there are some formulas that you do have to know for probability. So let's quick turn the page. The formulas you need to know: basic probability. Probability of A and B equals A plus B minus A or B. And the opposite of that is also true. A or B equals A plus B minus A and B. And again, remember that hill is and, the valley is the or. So this is the or, this is the and. Also basic probability formula. The probability of neither is the total minus the or, and vice versa. Or equals total minus neither. So anytime they give you the probability that neither thing is going to happen, you can subtract from whatever the total is to figure out what's the probability that either or would happen. Then we have now also talked about two formulas for independence. Independence is either the probability of A and B equals A times B, or the conditional independence formula, probability of A given B equals the probability of A. The last thing you also need to know is conditional probability. And remember, conditional probability is whenever you see the word given or known. If you're given or known, if you know something has happened, that's then the conditional probability formula. So the probability of A given B equals the probability of A and B divided by the probability of B. All right, if you have any questions, please send me an email or send me a message on Remind, and I hope you guys have a wonderful day.